Hey everyone, and can you see my screen? Just checking, double checking.
Yeah, it works.
Perfect. All right. Please let me know if something gets stuck in the way. You know how this works. It is technology. It is not perfect, so it could happen. But well, let's start it. As Diana said, I am Josué. Let me introduce myself. You were wondering who's this guy, right? Well, I am a senior software engineer. My main focus has always been Ruby. I've done some work here and there regarding other technologies, but Ruby is the technology I enjoy the most. You may ask why. I actually don't know, but through all these years, I found that it is a really flexible, really elegant language, and it has so much potential for other things outside the web development work, and that's why we are here now, right? We're going to try to discover it. So yeah, before starting, I would like to have some announcements for you. Let me let you all know that right now we are looking for developers, awesome developers on the Ruby community. And also, if you're not a developer regarding Ruby, but you know someone, you can refer that person and you can also win some referral bonus that it is always well received, right? But yeah, if you want to join a really awesome team, know really, really cool people to work with, this is your place. So please let the recruiter people know that you are interested, and we're going to get in touch with you. All right. Getting back to our conversation. So as many of you know, AI right now is like one of the loudest topics that you get AI everywhere. So you may ask, hey, why are you interested in AI and why Ruby? Well, I always been interested and really into AI, like since I've been like small kid, like when watching movies and you saw all those amazing things that right now are actually happening. They were science fiction in the past, but they are now like real stuff. So that caught my interest since pure beginning of my life. And then why Ruby? Well, that's my main language, and I know that the potential of Ruby goes far beyond the web development. So we're going to dive in a little bit deeper and see why Ruby is a good option. No matter we have like strong options right now that are dedicated to that. All right. So why Ruby? We have Python. Yeah, I know. When people tell me this, I usually answer back with another question. Why not, right? If we like narrow ourselves into why this, if we have this other, you're never going to discover like maybe in this other part of in this other side of things, you're going to discover something that is really cool and you can use to make your development easier. So that's why my question usually is why not. Sometimes people box themselves like everything can be done in Python, but let's say they don't have like so much knowledge on Ruby, or the knowledge they have is like due to web development frameworks like Ruby on Rails and other stuff that are really, really deviate from the AI topic. So today I'm not going to try to convince you to do it because myself, I am not an AI expert, but I really like this language. I think it is really, really simple to use, and I'll try to like plant that seed in your head and see how it goes, because we can make this community a little bit bigger if we want to. So we have some similarities and difference regarding Ruby and Python. They are like really, really close. And I'm going to compare these languages because those are the languages that well, Python is like the reference language. You know, Python is really widely used on AI and that stuff. And Ruby is the language that I think that could perform really, really well into this context. So they're both interpreted high-level language. That means that both are really, really simple to use. They are really, really close to the developer. So they are made to make your life easy when you work. Syntax is really clear. So they are like really depth-friendly. It's based on both its readability. You don't have to struggle to understand a couple of lines of code. You can be really, really productive on any of these languages. They are both elegant, flexible. We're going to dive a little bit deeper into that topic really soon. Dynamic typing, you don't know the types of the variables at development time. You know the types of the variables at runtime. So they are not explicitly declared like in Java, for example. And both object-oriented. You know, in Ruby, almost anything is an object. And in Python, we have really similarities to this. And then also we have some key differences. And these differences are the ones that have determined why Ruby is not into AI and why it is really into AI, but just in a really small part regarding Python. First is philosophy. You know that in Ruby, you can do anything like in 1,000 different ways and get the final result the same in all. You can have solutions like really intricate or really difficult solutions for one simple problem, or you can have like one-liner solutions that may look ugly, but you can do that. Python, different than that, there is like the philosophy of there should be only and preferably only one single way to do things and you stick to it. So as you know, Python encourages like single ways to do things, and for end thus it encourages clear coding and coding style. Like they try to box you to work the Python way, to say it that way. White space, we'll know Python is like really tabular language. You need to tabular your methods and your stuff in order to differentiate and to help the interpreter there. On Ruby, you are stick to code blocks that are like endwise block. I like to call it that way because you have to box everything into blocks. Also, community and ecosystem. Right now, Python is widely used in data science, machine learning, scientific computing, due to libraries like NumPy, Pandas, libraries like TensorFlow that are really powerful on deep learning stuff. Ruby is more popular in web development. So Ruby is like specifically, you all know that about the existence of Ruby on Rails. That's like the most widely used framework for Ruby right now. So it is like its main purpose. And then functional programming. Python supports functional programming, but it is not its strongest. On Ruby, functional programming is like more robust. You have something like procs, you have lambdas, you have blocks, and then you can interact that. Both are multi-paradigm languages, but functional programming can have some more tools here and there on Ruby. Final, concurrency. Python and Ruby, well, Ruby previous the version 3, they both had a global lock interpreter, which basically it is a bottleneck when you try to use the CPU in order to do multi-threading operations. On Ruby, after the version 3, that got that saw reality. Now you can use actual threads of your CPU in order to use concurrent programming. And you can have access, as I said, to those to your cores, to the actual threads on your processor in order to execute tasks parallelly. So Ruby 3 had really cool updates, and we're going to dive in a little bit deeper in the next slide. So basically similarities, differences as in your language, but they are really close regarding performance. You can just find out in the web that there are several benchmark tests, although I don't believe too much in benchmark because we're going to see it in the next slide why. But yeah, pretty much really close languages. All right. Now, we're going to understand the roadblocks that Ruby has in face of the AI. So first block, I already talked a little bit about it, but it is the over-focus on web development. Right now, I actually place here like a couple of the most popular web development frameworks we have for Ruby. These are just to mention a couple, like Rails, Hanami, Padrino, Sinatra, 𝐉𝐸𝐻𝐻𝐸, Grape, Rhoda. You can name like an infinite amount of web development because we have had an over-focus on this topic. I think that leads to our second roadblock, and it is a bad reputation. Ruby has some sort of bad reputation about the slowness. And that's not because Ruby is bad. You know that you can do anything on any language. And the performance, as I mentioned before, it is not really tied to benchmarks. Although talking a little bit about benchmarks, in some part, in some tests, Ruby performs even better than Python, and in other Python gets the lead. But when you talk about slowness, you have to think about like if you are dealing with a web development framework that is actually queried to the database. So now your language also depends on how fast is your database and how fast your query is going to resolve. How good is your query and how good your language interacts with that query, like through the DSL that they may have or the ORM that they use. Also, let's say that your language also depends on libraries or extensions written on C, which Ruby does. Now you depend also on C compiler, right? If those extensions are like really optimized, they're going to be faster and they are going to make the language faster. But if not, they're going to be a bottleneck. So it is like measuring how good performs or not a language under certain benchmarks is like a little bit deceiving. But yeah, Ruby has a bad reputation mostly because of the web development frameworks, and not all the time are like really, they not explode the actual power because they need to do their own things. For example, Ruby is really bad at rendering HTML. That is tending to change now with recent versions where they kind of introducing React and other stuff. But yeah, they have always struggled with that. And then the final one is the ability of transfer responsibility. You know the old saying that says, allow me to be redundant on that. Why you are going to reinvent the wheel if you already have a wheel, right? I know that that's not the specific saying, but it goes something like that. So if you have some libraries that are already in Python that are really well performant, like really strong, why are you going to rewrite that in Ruby, right? It is like a little bit of nonsense. Maybe you can have like that urge because you really like Ruby and you are going to know that Ruby is going to perform a little bit better. Maybe not, but yeah, we have that. And because of that ability to transfer responsibility, Ruby has something called sweeps. Basically, they are simplified wrapper interface generators, which basically they are wrappers to other libraries in other languages. And I can mention a couple. We are going to dive in a little bit deeper, but I can mention like there is really popular library called liblinear for machine learning and solving machine learning problems. You have their own gem in Ruby, which is called liblinear Ruby, which basically is a suite to liblinear. You also have libsvm, which is another really powerful tool to tackle problems regarding support vector machines. You have its own version on Ruby, which basically is a wrapper called libsvm. And also scikit-learn, a really popular library on Python. You have its counterpart on Ruby, which can be called using a gem called PyCode. So that way, some people think that it doesn't worth it to rewrite everything if you can explode like the power of another language in your own language. Okay. Let's continue. So, is really Ruby out of the race or not? We're going to talk a little bit about this. We can dive a little bit into why Ruby is not out of the race. And this is like the first thing I can present. This is the first snippet of code. So I don't want to make myself boring. So you're going to see code through all the presentation. But let me explain what's happening here. Ruby has a really high flexibility and versatility regarding coding. And Ruby, you can do really crazy stuff as the stuff we are seeing right here in the screen. And basically, what we are doing here is open one of the core Ruby classes, which is called string. You know, string is almost in any language, and we are modifying the split method. So, for example, here at the top right, you have some results. If you have a string like hello world, and you split the string, and you don't pass any parameters, the word is going to be split into the sentence is going to be split into words by blank space, right? And if you just add a blank as the parameter, it is going to split everything, right, including the space. So what I'm doing here is I am modifying the string class at runtime using this cool method right here that we are going to be diving deeper called class eval. And what I'm doing is if you don't pass any parameter, like for example, delimiter and limit are nil, both, you're going to be using a different version of the split. Now you call it without parameters, you get this weird stuff where you are just dashing all letters. I know that that makes no sense, but my purpose here is like let you know how powerful is Ruby when it comes to flexibility. You have access almost to everything there. Everything is like really modifiable. Like really, you can update even like the classes that have its own interface to C interfaces, to C extensions on Ruby. And that can be a little bit messy, I know, and it is scary. Actually, we don't use this too much, but they introduce a new way to evolve, right? Ruby can evolve based on your code. So let's continue with another really cool feature Ruby has. And well, this is a reference to Matrix movie. Really cool movie. As I mentioned before, I was really into all this stuff since I was a child. So here we're calling Enter the Matrix. And what is Matrix? Well, Matrix is one of the core libraries or gems Ruby has. And it has been there from the pure beginning. So as you can see, Ruby's purpose was not like web development from the very beginning. It was something bigger, something higher. And since 1998, we have this library, which took its implementation based on the original library from Smalltalk, which is a functional language. And it was developed by none other than Mats, which is like the creator of Ruby. This library is heavily oriented to tackle really hardcore powerful operations over n-dimensional data. So that's why it is called metrics, right? You can have operations like transpose, you can have like operations over two matrices, you can have the inverse, you can have stuff like that over several like heavy amounts of data. Also, it has great support because as I mentioned before, it has been there from the very beginning, and even to today, it has some commits in there. So it has been optimized, and actually it is the foundation for other gems as the one you can see down there, that one. We have in Ruby something called NUMO NRA, which is a gem and a class that actually explodes the power of matrix, of matrix. And using that power, it performs really well. And actually, that's the main gem used on Ruby gems dedicated to AI and machine learning, deep learning to tackle heavy operations. As you know, there I place another one is NumPy. NumPy is a Python library. It is not used in Ruby, but NUMO NRA has its base on NumPy. So that's some sort of reinventing the wheel. Ruby tried to emulate what we have on NumPy. And NumPy is a little bit powerful, more powerful than NumNRA. Because it has less community behind it, as you know. But it is widely used to solve problems like, for example, K-means, which is an algorithm on machine learning, in order an algorithm, classification algorithm. And also it is widely used machine learning frameworks we have in Ruby, similar to other frameworks we have in Python, like one called 𝐉𝐸, that we are going to talk a little bit more about that one later. Final one, it is metaprogramming. So I don't know if you are really into this metaprogramming stuff or if you are like really lost about it, but I can resume it in one simple word. Metaprogramming is basically code that writes code. As you know before, let me go back again. Here we are writing code, but we are not writing code that can generate other code inside of this class. We can do that automatically. And there is where metaprogramming comes in place. With metaprogramming, we have access to several cool methods in Ruby. Many of those methods are like really known by the Ruby community. For example, the method missing. I'm going to explain it in a little bit later. And we have other stuff that we can use to play with classes, or we can use to manipulate Ruby in order to allow it to generate methods on the fly for us. So that explodes Ruby generative capabilities. And I think that's something really cool that we can use together with AI to create some generative or evolving stuff. Like, for example, evolving algorithms or stuff like genetic algorithms with Ruby. Okay, let's go ahead. So what lies ahead? As I mentioned before, I think this is not widely explored right now, but I think metaprogramming is the way to go when you talk about Ruby and AI. It has nothing to do with machine learning or stuff, but it has a lot to do with generative capabilities. So we're going to talk about first method missing, and then we're going to talk about class eval and instance eval, that are two of the most powerful methods we can use with Ruby. Method missing. All right, more code to make you awake during this journey. Please bear with me. I'll try to explain this the best as I can. In Ruby, everything is an object and everything has a hierarchy, right? You can instantiate a class, one of your classes. You can create an instance as in any other language, and that class can go back in their ancestors chain until it reaches the basic object class or the basic object library or gem. As you want to call it, but it is going to reach the end. Basically, method missing, what it does is if you try to call a method, for example, here we have two results. On the first one, this may look familiar for you. It is like in Ruby, it is called hashes. In Python, it is we have something similar called dictionaries. And we are instantiating one. We are accessing this key in order to get the value, which is 1. As you can see here, we have the value. And then you can override that value. You can update the values in a hash. As you can see here, we are now assigning to A the value of 7. And then you can access the entire stuff. And you can see that now A, instead of a 1, it has a 7. Now, if you want to access the value of the key A inside the hash A, as here at the right part of the screen, you're going to get this error. And here below, you can see that there is one exception called no method error. What this is doing, it is trying to find the A method in the hash class. But since the A method doesn't exist because A is just a key, it is not a method that we already have written, it is going to try to now, if it doesn't found the method in hash, it is trying to get through the change until reaching the last, the pinnacle of the hierarchy, which is the basic object. And if it doesn't find the method in none of the ancestors chain, it is going to trigger the method missing method we have from Ruby, which basically raises an exception as the one we see here, which is the non-method error. Now, we can use metaprogramming to do something crazy like this. I'm not going to dive really close to the code, but here we are overriding. We are opening the hash class. We're overriding, or we are accessing to a new method we call method missing, which also has the name of the actual method we already have in Ruby. And this method is going to be an intercept. So if Ruby is not going to find a method, instead of going back on the ancestor chain, it is going to fall here in this new method, right? And this new method is going to take the method's name that you're passing, in our case was A, as you saw. And here is code I created to manipulate the hash. And instead of returning one error, now we are going to return the value if it is a setter method, and a getter method, and we are going to override the value or update the value if it is a setter method. So basically here, this code is generated at runtime. This code you guys can see here at my right part of the screen. It is defining a method A, which basically it calls self, which is the context we're running the method on, which is the hash. And it is taking what we have in the value of A in that key. And for the second method, it is creating a setter, which basically it is updating the value. So if you see here, let me go back again. Basically, we're doing this. The stuff we did here for getting a value and for setting a value, we're doing that, but in a dynamic way. So next time, if I copy and paste this in my console, and then I do the same, I instantiate a new hash with those keys, and I want to access a key like this, now it is going to return the value of 1. Instead of returning that there is no method like that, actually, we didn't write the A method explicitly, as you can see, but we use the powers of method missing in order to generate that on the fly. And similar for 8.A, if we assign something new, like for example, this value, which is really explicit that says replaced, and we print everything inside 8, you're going to see that the new value is replaced. So it is working as expected. And again, this can be exploited to the maximum to generate other stuff. So pretty scary, but pretty cool. Let's go further and let's explore what about class eval and instance eval. This one is like I can explain this with the example a little bit better. And what I am doing here for the Ruby people, they are like really used to work with some stuff called accessors, which basically accessors are like not other than instance variables and that have its own getter and setter, and you can get access to attributes on a class. For example, here I'm instantiated a dog class, and I am creating accessors for that class, and the accessor is name. But as you can see here, I just made up this method. This method doesn't exist. That's why the interpreter is saying that, hey, you have an undefined method, which is custom accessors. That method doesn't exist. It is triggering again the no method error, which is triggered by method missing. So what I can do here is something crazy like this. Here I am opening the object class, which is one of the oldest, to say that, talking about ancestors, it is one of the highest hierarchy classes and the hierarchy. And I am using instance eval. Instance eval, basically what it does is it opens an instance of that class for you to add new methods. Let's say you have an instance of a dog class, you have dog.new, and then that instance is called dog1. You can do something dog1 dot instance eval, and you can open that instance and you can add classes and, sorry, you can add new methods that only going to work for that specific instance. Here, this works with Ruby because everything on Ruby is an object. And actually, object is an object which has its own parent class. So here I am opening an instance of the object class, which is going to be used on any other objects that we are going to derivate in the chain. And I am adding this method manually. But the cool part here is that what I'm doing here dynamically is the attribute names I'm passing. In this case, we are just passing name, but let's say I pass age, where I pass height or weight. For any of those attribute names I pass, I am created on the fly getter and setter methods by looping through the array of names and then created the methods on the fly using class eval. And if you're really into how Ruby accessors work, this is the way they work, right? Something similar to that. So having that, I can now call custom accessors, pass the name, and then if I instantiate my class, for example, dog is going to be a new instance of a dog.new, and I set the attribute name, which I already have because this is allowing me to do that, to Fido, then I can just get the name. And here I am just doing an upcase just to let you know that you can manipulate this as you want. So pretty cool. Another way to generate code on the fly out of pure dust. You just generated a bunch of setters and getters for your attributes without having too much code explicitly to do that. All right. Let's dive deeper. Now, with that out of the way, with the base of that your capabilities are really, really like strong to do stuff here, what tools we have right now that explode that and also explode other stuff to play with AI in Ruby? Okay, here I have some related gems and tools that you can use right now on Ruby to solve problems and stuff related to machine learning, deep learning, stuff that you may need neural networks. And we're going to dive in deeper into some, but here I just have a couple. But instead of just enumerate some, because as you know, this is an introductory talk, I am not going to dive really deep into all this stuff because that will make this call like 10 hours long. But I just picked up a couple here and there. And one of those, I'm going to explode with examples how to use them. Let me do one pause because I see some comments in the chat. All right. All right. I will get back to this at the end of the call. But yeah, please, if you have questions during the chat, I know that I am really hyped talking about everything, but please don't hesitate to jot that down in the comment in the web chat, and I will go back at the end for questions. All right. Yeah, getting back to the presentation. Here we have I divided this into 3 categories: gems, frameworks, and wrappers. I already talked a little bit about gems. Gems in Ruby are like the libraries or the packages we have in other languages. Here I just mentioned 3 because we don't have a lot. We have more than these, but let's say other gems are not as supported as we may want right now, and maybe other just got left in the past. Like they were like tries to do something cool in Ruby, but the community didn't follow up. So first, we have Ruby linear regression gems. We have quite a lot of these because linear regression is like a really popular problem we use on machine learning to predictability and to solve predictability problems. In 𝐉𝐸𝐻𝐻, which is like the Ruby machine learning framework, we have actually classes to deal with this. We have also K-means cluster, which is a gem that has also good support right now, and it is to solve K-mean problems, classification problems. And then RubyFun, which is a gem that explodes the fast artificial neural networks on Ruby. Then for frameworks, we have these two. I know we have more, but I just wanted to summarize these in two. We have 𝐉𝐸𝐻𝐻, which is really strong, really well supported right now, really used. And then we have EPS, which stands for epsilon. And also it is dedicated mostly to machine learning and to deal with the stuff regarding classification problems and other sort of machine learning stuff. Okay, then finally we have the wrappers. For the wrappers, we have some like TensorFlow, Torch, LibLinear, libISBM, Ruby OpenAI, Pickle. And from all these, we're going to dive into Pickle, which is a gem to call functions in other libraries. So let me start with Ruby linear regression. Here now we're getting to the meat of the sandwich, to say that way, right? We're talking about what we can do in Ruby. Okay, linear regression may be a fuzzy topic for many of you. It was for me. I think I saw a couple of things regarding this in the statistics in the university, but we can refresh a little bit. Basically, in linear regression, you have two collections. One collection is a set of data, which is independent data. In our case here, we have variable X, which is hours of study. And we have a dependent variable, which usually it stands on the Y-axis. And in our case, is the G3 score, final score for one course. So basically, we have a collection of data, and if we graphic that data, we get this graphic you're going to see here. You're seeing right now here in the screen. As you can see, the tendency for the points, it's like linear. You can see that you can trace a line like that is going to not traverse across all the points, but it is like it has its form, right? It is like a progressive line, because one of the things we need on linear regression is progressive data. For example, hours of study is something quantitative. It is progressive. It is not qualitative. And then we have results that have a tendency to correlate in a linear way. So when you see that in a graph, you are facing a linear regression problem where you can solve that and you can predict new values. For example, I can add a couple of new hours here, and you're going to get like accurate values on Y. So a linear regression is actually for that, for predictability and for getting new values out of the data you already have. This is a problem that where we have to know all the data beforehand. That's why they are called supervised algorithms. So you have to provide the entire set of data before starting. And then once your model has been trained with that data, you can solve new, you can predict new values with new data. So you don't have like testing data like in other AI problems. Here you can see a function. This is usually the function we use for two-dimensional linear regression problems. This is two-dimensional because you have an Y-axis and an X-axis. And it is positive because you see the tendency to go that the higher the values on X, the higher the values on Y. If we had, like, for example, instead of hours of study, we had something like hours of video games or hours on social media, maybe the tendency on the G-score is decreasing. The more hours you have on your social media, the worse are going to be your grades, for example. In that case, the function is going to be negative. Now, what we do on linear regression problems is try to find the best function as possible, the best line that fit those points. And we're going to see that in a bit. But for now, in this function, alpha is going to be the slope. The slope means like the inclination that you have on your line through the points. And then beta is going to be your y-intercept. It is called y-intercept because it is where your line traverses the first value on y-axis, your line in y-axis. You can have multi-dimensional data here as well, but we're going to focus on just one independent variable, in this case, x, and one dependent variable, y. So let's jump to one exercise to get this a little bit better and how it works on Ruby. We have an example here. And for this, we're going to use this. This is a gem, an actual gem. You can look for it. It is called Ruby linear regression. But I recommend use 𝐉𝐸. It is a little bit stronger. It has more stuff. You can get the R squared on 𝐉𝐸. R squared is like a measure in order to know how good your line fits the points and how good is it predicting your values. So basically, with R squared, you can identify your problem is an actually linear regression problem, or if your values in X don't correlate to your values in Y. Here's our problem, the one you already know, the one I already presented. Hours of study is our input, and then we're going to predict based on the hours of study, the final grade. Let's go and see our data. It is a simple CSV. I made up this data, so it makes not sense. It maybe makes not sense regarding the grades. As you can see here, we have a grade of 24 or something like that, but it is just for testing purposes. And to make this fun, entertaining, here's a little bit of code. Again, let me walk you through the code and what it's doing. It is really simple. As you can see, just with these chunks of code, you can just have linear regression problem solved in Ruby. First, we're requiring a couple of libraries. CSV is just to have a read of this file and load our data. Ruby linear regression is the gem we are using. After installing, we're just requiring the gem. And then we have this function I just created to load the data. As you can see, we're looping through the file. Basically, that's what this block is doing. And each row is going to be injected into the X data, which is the independent data, and into the Y data, which is our dependent data. It depends on X. Next, we are just instantiating a new model using the Ruby linear regression library. And finally, we are loading our training data. And what this is doing underneath, when we call train normal equation, it is running all the calculation, but basically it is finding this line right here using a method that we can call cross-validation. Cross-validation is a widely used technique on statistic, which basically uses the data to evaluate if a sample of independent variables is good to predict dependent variables. Basically, it is widely used in problems of machine learning regarding linear regression, regarding k-means, regarding SVMs, neural networks, and other stuff. So that's what we are doing right here. By the way, these are methods that are from the gem itself. I didn't write any of this. So I just using the game to let you know what we can do. And then once you train your normal equation, now you can predict new values. And here I am passing a new collection of hours of study. As you can see, we have 30, 2, 45, and 5 hours of study. And for each new value that we are introducing, we are going to predict which is going to be the final grade. And for that, it is the predict function you can see here. Predict function, we're passing just the hours as an array, and then it is returning a predicted grade. So let's see the results. For our set of 4 new points of data regarding hours of study, we're getting that, for example, for a student that studied 30 hours, the final grade is going to be a 48. For a student that studied 2, final grade is going to be a 1. For 45, final grade is going to be a 74. And for 5 hours of study is going to be 6. So I know that the hours may be crazy and also the grades, but as you can see, also our results have a tendency to be linear. The higher the hours of study, the higher is going to be your final grade. That means our predictability linear regression model is actually working as expected. All right. Let me just check again the chat to see if we have something cool. Okay. Yeah, we're going to All right, yeah. For the gems, yeah, as I mentioned, we have a couple. I can recommend a little bit more, but for machine learning and starting machine learning in AI, this is a really good one. Linear regression is a really simple problem. It is when your data behave just linear, and you can just use new results to, as I mentioned before, to predict. But there is another gem that is really, really simple to use. Let me show you here on the list again. This one, K-means cluster. I didn't have an example of this one, but you have like a lot of data there. And K-means is a really powerful tool to classification problems. All right. Let me go back to the presentation now. We're going to talk about like a really cool classification problem, which is called SVM. So let's dive in a little bit deeper regarding SVMs. So what are SVMs and what is PyCall? As I mentioned before, PyCall is a wrapper for Ruby in order to allow you use libraries in other languages. For example, we can use libraries like scikit-learn on Python, and you can call that on Ruby to solve SVM problems. So what is SVM? So let's assume you have a problem like this. Actually, this is going to be one of our examples. You have med dosage and milligrams, and you can you want to determine whether or not your the amount of milligrams on your drug dosage, your med dosage, is going to be effective or not on a collection of individuals. So if the dosage is too low, it is not going to be effective. But if it is high, it is going to be effective, at least in our first model. What we want to do with support vector machines, SVM stands for support vector machines, it's to find the best way to divide this data into groups. That way, you're going to establish exactly whether your dosage starts to be effective in our example, and whether it is not going to be effective anymore. Or whether it is effective, whether it starts to being effective, and then if you surpass or if you get more of the needed dosage, if it gets unaffected or not, similar as in our second model. So the technique to find the right point in this case, or the right line that divides your data, is the actual technique that we follow on SVMs. As you can see, let's say for the first example, we placed a point here, but why we didn't place it here, right where the data behaves like in a different way? If we do that, we're going to use like really strict margin, and we're not going to like we're going to allow a lot of misclassifications, because since the margin is too close, for example, one point that falls between these 2 points of milligrams is going to be really difficult to classify. So we tend to use soft margins. That's called soft margins, and we are dividing the data where we know that we have a better classification. The trade-off of that is that we have errors. For example, this guy right here is really misclassified, but it is an error that we are allowed to have. So as you know, in all these problems regarding statistics, we have a code of errors that we can play with. But what happens when our data behaves like the one that we have in the second model? You know that there is no way to place one line and have it like strictly all this group is going to be effective and all this group is going to be ineffective. In that case, there's where we introduce the algorithm of SVMs. Basically, the algorithm, what it does is you start with a lower level, to say that way, divider, and we start moving from that lower dimension to a higher dimension. Why? We're trying to find a function that best divides our data. And by doing that, we are getting the actual data divided. If it is not possible to divide it in one dimension with just one attribute, for example, here we are just dealing with milligrams, we can add something new. Like, for example, instead of the amount of dosage, we can also add age or add another quantitative way to measure this in order to have a better line that divides our data. For example, in our next slide, we added to the milligrams of med dosage, we square everything up. So, for example, our first value is stayed there, but for the next value, let's say it was 0.2 milligrams. After a squared, you get a y value. Now we're introducing a new axis. And then, for example, here, once we transform our data by squaring the values, you're getting actually a way to trace a line, and then to get your data classified. To this method, to moving from lower dimensions to higher dimensions using kernel functions, that's in theory, that's what we use in order to do that, is called SVMs. And most of the time, these functions are going to be polynomial, but they can be also radial. They can be functions of other forms or line forms, to say that way. But for the simplicity of our example, we're going to just get here. And the best line that fits the data usually is called a hyperplane. It could be a point, as we saw before, and it could be a line. And if we had like a third axis, it could be a plane. And if we have fourth axis, it could be like something four-dimensional that we call just hyperplane. All right, what are we going to do? Here we have a new example. As I mentioned before, we're going to use PyCall, which is a gem in Ruby. For who ask why, what's a good way to, like, for example, transition from Python to Ruby. This is a really good one because you can get almost any code you fixed on Python or any problem you solve on Python, and you can translate it to Ruby just by using PyCall. And for the SVM problem, the solver, to say that way, the library we're going to use is scikit-learn, which is Python library. This is the problem, and it is a classification problem. Basically, we're going to train our model to recognize numbers. We as humans, we are really, really good at recognizing. For example, you see this and you say like, oh, it tends to be a 2. Maybe another person is going to be, no, it is a 3. But with good accuracy, they are going to be like if you have a sample of people, they're going to most of the time pick the 2, right? So, and those errors are the ones that I was talking before. And we as humans, we do those errors. And now we can also quantificate those errors on machines. So our problem is going to solve this. And we are going to use one testing set that it is available in 𝐸𝐳. And using that testing set, what we are going to use is train our data, have 80% of data for training and 20% of data for testing. That's a technique that is usually done in machine learning, where you use the same data for training and testing, but in different proportions. Right. Let's go to the code. Here, as I mentioned before, I am using PyCall. I am importing PyCall. And then these are the packages I'm going to use. Scikit-learn, sorry, this data is not from 𝐸𝐳. Let me rephrase that. It is from scikit-learn side, where they have like data made by data scientists for you to test and also solve your problems. The data set is called, the one we are going to use is called low digits. Basically, it is a data set where you have a matrix of 8 by 8 numbers. As you can see here, you can form 8 by 8 numbers here. At least in our data is that way. And basically each cell contains a gradient value from 0.0, which is white, until it reaches 16.0, which is black, full black. So here you can tell that this is 16, but here that you don't see anything, it is like a 0.0. And using that, we can quantify that data using those numbers to train our model. So what I am doing here is loading the data after calling the required libraries. And then I am just reshaping this data because on Ruby, that's something to point out. On Ruby, the objects that Python returns may not be as user-friendly for Ruby, because Ruby don't understand how are Python vectors or arrays. So we need to like some sort of reshape data. Luckily, we have some methods to do that, like for example, shape and reshape. That's what we are doing here. And then we are dividing our training and testing data using train test split, which is a library from scikit model selection library. As I mentioned before, here we're using just for test side at 20% of the entire amount. Then the 80% is going to be for training the model. Now, here we're instantiating our SVM machine using SVC, which is a C-class support vector classification algorithm that we have there in scikit-learn. You can dive deeper in the scikit-learn site if you want. But for instance, we are just assuming that this is going to work like that with this gamma. Now, I just can tell you that gamma is, I can explain like really easy to say which influence have one point over the other points. For example, really quickly, let me go back. Here I want to know which influences have this point and this point on this point. The amount of influences, the points are going to be one over the other one, closer, is going to be determined by that gamma attribute here. Now we are setting at 0.1%, which is really, really low influence. And finally, we are scoring our classification method. Based on this score, it is going to be like the R-square we have in linear regression, but in this case, it is for SVMs. And basically, it predicts if your data is well fit, like if it has a high percentage to be like really, really well distributed based on your inputs. And finally, we are predicting. As you can see here for the prediction, I am using the test data. And then what I'm going to do is I created this grayscale converter. Is a really, really simple function because in the console, we don't have like well, you can have access to print images and stuff, but I wanted to do it using ASCII because it is easier. So once we test this, you get something like this. For example, here I'm just calling the script. And as you can see, our prediction score for the first example is 98.89, and it is predicting that the number we are passing is an 8. This is the actual input we are given, and this is the actual output. As you can see, it forms an 8 on ASCII. If we had like video memory or something like that to play with, I ran this in a Docker machine, and I didn't want to complicate it a little bit, but you can see like some kind of 8 similar to these weird numbers right here. All right. And then for the second example, I just rerun this, and with a 98.7% of accuracy, it is predicting that the number we're passing is a 4. So now our model is recognizing numbers based on our training data. So that's really cool. And that's one of the main reasons we have SVMs. SVMs are like for recognizing images, medical disease, and other stuff. Now, we're going to enter to the final topic of the conversation, and it is natural language processing. I'm not going to, again, dive really, really deep because you know that this is an introductory stuff, and I wanted to get around a lot of really small concepts. But we can also, in the future, dedicate an entire topic to this. But yeah, in Ruby, it is possible to get some NPL or NLP, natural language processing. Bad thing is that the support is really, really low. So it is our fault. I think we are letting this die. But I'm going to show you that also using PyCode, you can resolve problems of natural language processing. For this, we're going to make use of something that is fuzzier than the other algorithms, and it is more for deep learning, and it is called artificial neural networks. Now, this is a really wide topic, really heavy one. So I'm just going to let you know that this is formed by neurons that are your inputs. Then you have hidden layers of inputs connected to other layers where we transform the data, and each connection is going to have weights, numerical weights calculated by functions. And those functions are going to be necessary because they're going to like weight the data and distribute the data you get in your inputs, and then transform the data to answer back once they reach the output. So, the functions that connect one neuron to another can be of any forms. You can have soft plus functions. I also remember we had another function called sigmoid, which is really used. So that's the one we are going to use. The form is sigmoidal. And then something like the ReLU function, which it stands for rectify line unit function. Most of the time, those three are really, really widely used. But well, you know, this topic is not like one of strongest in my arsenal, but I did some investigation and we have that. For natural language processing, what we are going to do is follow this algorithm. Basically, we are going to get full text, and based on that text, we are going to split it into simple lines, and it is going to be called segmentation. Then the lines, we're going to split them into words. That's called tokenization. Then stemming is basically having from one word its roots, and then you can derive other words from it. For lemmatization, basically you are giving us a sense of identity to the words. Then we're going to tag those words, for example, see if they are verbs, nouns, pronouns, and stuff. and then give a sentiment to the document. The sentiment is like the emotion. If your document is talking about something sad, like if you are asking ChatGPT, hey, I feel sad because this and that, or I feel really happy. That way, our model can check if your words are actually expressing that. Let's go to the example real quick. For now, we're going to have an identity. We're going to identify sarcasm in the context of a document. So basically, we're going to pass a sentence, and our model is going to see in determining if we are talking with sarcasm or if it is actually something real. So we're going to be using TensorFlow through Python. And TensorFlow is a Google library, really powerful, amazing library to deep learning. I encourage you to investigate a little bit more, but we're just going to scratch the surface regarding that. This is a simple example where we're just tokenizing. Yeah, because I want you to understand that tokenization is the process where basically you get a sentence into words. You have some classifications for the words. For example, you create a dictionary of words based on the keys you get. And then you can also weight your sentences. And also you can have sentences sorted in some way. For example, I love my dog. It is pretty similar to I love my cat. But for example, if we have the value of 1, 2, 3, and 4, for this one, we're going to have the value of 1, 2, 3, and 5, because cat is a new word. And then based on that, you can also sort, you can give a sentence that I love my dog is an actual sentence by adding to the entire sentence one numerical value, right? So what we're doing here, we're calling the tokenizer class from Keras TensorFlow. We are getting a number of words. This is the maximum number of words we want to keep. And the OOB token is in case in our testing data, once we train our model, if it determines that there is a word that they don't know, instead of losing that data, it is going to replace that word with OOB, which is a token, basically. That way we lose data, but not so much. Then we turn out an important one, the text into sequences. So we are actually using those words to create sequences that actually have their own identification. And then based on that, we pad our data. Padding our data is that, for example, if we have different length data, for example, here, the final one is really long, we can pad our data adding zeros. And that's a technique that is used in order to have like matrices, because doing operations over matrices is simpler than over the vectors. And finally, we are going to test our data. As you can see, basically, we are passing testing data. And here in our results, as you can see, if we pass the first one, as I mentioned before, it is creating like a dictionary of words. And then for the second one, it is adding like the OOB tokens. And then you have the sequences and your sequences palette. Now, why this is important? Well, this is what we are going to use for our sarcasm detector. We're going to use now, this is actually testing data that we have in Kaggle, and it is data for testing for news. So it is basically ranking news based on the headline. We're not going to use the link, but based on the headline, it gets if it is sarcastic or not. So this is the data we have. And with this data, we're going to train our model. Basically, we parse the file, load in the data. Pretty simple. Basically, just load the data and then have the sentences, which are these headlines, into the testing data, and the labels, which are if it is sarcastic or if it is not sarcastic, in our testing data as well. Then after that, we, again, the same as before, we use the tokenizer, we use the amount of words we want, and then we use the OOB token. We feed our testing data, and finally we pattern, similar as the process we did with the tokenizer before. Then here's where we are going to use a new concept, which is the neural network. We're going to use an embedding neural network, which basically what embedding does is, let's assume we're going to measure your words on sarcastic or non-sarcastic, and based on a pointed, we are going to give a score. If the score tends towards to be sarcastic, we're going to place your word. So the more your model trains using these epochs you see right here, the better is going to be determining if the words are going to be sarcastic or not based on your embedded model. Again, we can dive deeper this maybe in another call. But let me show you the cool part. Once we train our model, as you can see, for first stages of training for the first epoch, it has a really low accuracy, but then it starts increasing the accuracy and it is minimizing the loss, right? And then similar for your testing data. So that's really good. The training process, when it reaches 30, it is going to stop, and then you can now predict. What we are going to predict in our sample is these 3 sentences. I am 100% sure it is going to rain soon. My second sentence is, inside my bed lives a monster. And the final one is, the man never landed the moon. So basically what I'm doing is converting again these sentences in tokens. We convert them in path sequences. And then finally, I can call the predict model to see if my model now can predict if it is sarcasm or not. And here we have the output. For the first one, it is predicting that it is a 0.001% that this is sarcasm. The more closer to 1 this gets, that means that it is sarcasm. So our model is saying it is really low percentage of sarcasm, that this is actually sarcasm. And for the second one, it is really high. As you can see, it is a 0.8. So inside my bed lives a monster. It is able to determine that this is a lie. This is sarcasm. And then for the final one, the man never landed the moon. You know that it is a weird topic. So it is saying that it is a 0.1, a 1% from 0.1% of the entire stuff. So you can see closer to 1 indicates high sarcasm, and our model is able to do it. Now we can refine this. Actually, the padding, instead of padding, there is another algorithms that are used. But for the sake of this example, which is a little bit introductory, we're using this instead of something like RAG tensor and stuff like that. So we reached out the end of our presentation. Okay, let me just go through some of the comments. With all libs, for example, yeah, a PyCall doesn't work for all libs. Yeah. All right.
I will. Sorry, I just interrupted you for a bit second. I just ask you to read out the questions, so we will have them on the recording, the question and the answer.
Perfect. Okay, let me go over some of the questions. What gem, lib, library, framework will you recommend to someone who is started at AI, ML, and Ruby? Well, yeah, I think I already answered that. That's cool, interesting. If we are prototyping some startup projects, how does Ruby handle performance and scalability when working with large datasets? Yeah, there are several benchmarks out there. You can just look for benchmark Ruby 3, which is the most accurate. And then there are several comparisons with AI and complex AI models on Python, and it performs really, really good. Sometimes it performs bad, sometimes it performs good, similar to any other language. Are there specific types of projects niche where Ruby has particular advantages such implement? No, there is no advantage. The purpose of this conversation was to let you know that you have more tools. There's not only Python, and also the flexibility Ruby has regarding coding. Ruby regarding coding has like really, really heavy potential, but I think it hasn't been exploited yet. Then I have through before your talk, the Ruby is for web. Well, how do you recommend, for example, to integrate an LLM into web applications using Ruby? Well, you can use wrappers. I think there is, as I mentioned before, OpenAI wrapper on Ruby. You can have something similar to that. And we have other alternatives. Maybe I can elaborate more regarding another conversation in the future. But yeah, right now, I think the mostly used, the one I see is using the OpenAI stuff we have there. And yeah, PyCall, I agree with you. It doesn't work with all libs. I think the support on PyCall is really good. Actually, it has some good support right now. But as I mentioned at the pure beginning of the conversation, our community regarding AI, and I say our community, I was there, but I already had my investigation process. But yeah, it is really, really small regarding Python's community. But yeah, that's what we have. Do you recommend to use Scikit or some similar tool, for example, processing large dataset? Well, Scikit and stuff like Rescue and like that could work, right? But actually with some of these gems, we already have some parallel processing going on. So I don't know how that's going to interact with something like running on Redis or some sort of tool similar to that, similar as Scikit use or Rescue or something similar. But I think it is a really good topic to investigate. Can we implement that RAG in Ruby? Yes, you can. Actually, you can ask anyone that's working on that. For example, like something like recognizing fruits or something really, really simple. You know, RAGs are like a little bit more advanced topics, but since in Ruby we have access to anything. I don't know how is the vectorization process there and how it's going to behave, but you already have powerful libraries, as I mentioned, NRA, matrix. So basically that. Yeah, I don't know if anyone has more questions. And if not, well, my conclusion is that, yeah, the same as you said, I love Ruby. What real advantages of using Ruby in conjunction of Ruby and Python looks weird? Yeah, it does. Does it make sense to use intermittent storage for some data? I think like if you're going to store that in some sort of database that is not non-relational database, maybe it could work, but that is going to add some more complexity to the stuff. But that's something that actually is really used right now. You know that in AI, what limits us is the power of processing, and also that makes us slow things. The more things you add, for example, as you mentioned before, well, another person mentioned before, Scikit Rescue. Now you're mentioning like maybe object-oriented or object-related databases, because relational databases, I doubt it. But yeah, it could add more complexity and also more time and money to the equation. Advantages, I will say just the code, the readability of the code, and also the benchmark says that Ruby is really fast compared to Python. The only thing we are missing here is just more community and more support. And now that Python is like light years ahead, it is really difficult to catch up. Let's think of Ruby about like the new kid on the block that it is not new, but never learned to walk until year 5, something like that. Yeah. And for conclusions, well, all these could be conclusions as well. Ruby is like not perfect as any other language, but it is a really, really good tool regarding code. If you want to code at ease, please try Ruby. And if you don't like it, you can go back to Python, and that's totally cool. But yeah, that's one of the main reasons I wanted to also investigate about this. Is there something good we can use on Ruby? Yeah. Okay, for aesthetics and taste, business pays the bills, and it will be difficult to justify to stack instead of because I like Ruby. Yeah, totally agree. Yeah, that's something that we cannot do actually in any part of life, right? Why Ruby? Well, I like it. No, but yeah, and performance Ruby is really good. Encourage you to take a look. Ruby versus Python has advantages in functional programming and concurrency. Could it give in features some perspective of performance with common Ruby and AI and big data problem? Could it give? Yeah, I miss that. Maybe that's a really good point. I can maybe for a future talk a little bit more about what are actual advantages. I didn't do a Ruby versus Python thing. Basically, I just took some similarities and differences. And I tried to point out what are the strongest part on Ruby, which is like coding, and also it is good at performance. As you know, we cannot have like a lot of stuff done because performance, Ruby has bad reputation, as I mentioned at the beginning of the talk. And web development has killed that reputation regarding performance. But if you take Ruby as its own, like as the language for programming and perform concurrency and stuff like more like functional programming, it is really, really powerful. Actually, it is not as widely used as Python, but there are some stuff going on here and there. Ruby is more fun to code. That's a big reason to use instead of Python. Yeah, well, I agree on that. But yeah, maybe you're the guy that is going to pay for your project doesn't agree. But yeah, for passion, you can do it. Actually, I do this for passion. I like it. And also Ruby pays well. So yeah. And yes, but yeah, I definitely has that on my to-do list. I can give maybe in the future another talk about more towards performance. How performant is Ruby versus other languages. I'm just not going to point Python, because if I point something like really old languages that are really good, Lisp, Smalltalk, maybe something like Prolog, they can smoke Ruby, but maybe they cannot. So yeah. Are there more questions, or are we good? What do you think about Ruby? Do you like it? Do you hate it? Yeah, if you have more fun coding, it will be you're going to get more productive. Yeah, totally. If you're motivated at work, actually that's something that drives you every day. I mean, you can work on anything, but let's say you are going to be on assembler or assembly code, which could be really, really fast for its closeness, but you're going to pass a really bad time. Reputation is really easy to create meta-alien code in Ruby, which will be absolutely not understandable by other engineers. Yeah, smart code in Ruby sometimes gets things messed up. And I call a smart code because some people sometimes can create something like really, really smart, maybe using meta-programming where they shouldn't, like something for tackling really basic web development problems. But you know the tools are there, and the tools have one purpose. And I think the generative capabilities in Ruby have also one good purpose, and they can be used for this stuff. But yeah, I totally agree. If you try to debug something that has a lot of methods that are defined on the runtime, you're going to be through a really painful journey. Yeah.